Welcome to The Explainer. Today, we are going to tackle a huge topic, artificial intelligence. I mean, what is it, really? Where did it come from? And, how does it all actually work? All right, so let's just jump right in with the question that basically kicked this whole thing off. It was posed by the absolute genius mathematician Alan Turing way, way back in 1950. This one question really launched this 70-year journey to create intelligent machines. Okay, so before we can really get into it, we kind of have to define what it is. But as you're about to see, that's a lot trickier than it sounds, mainly because even the experts can't seem to agree on just one definition. So why not start with the guy who literally coined the term artificial intelligence? This is John McCarthy. And back in 1956, he gave us this super classic, pretty straightforward definition. For him, it's all about one simple goal: making machines smart. Okay, now let's jump forward to a much more modern, sort of functional take on it. The European Commission, they really focus on what AI does. They see it as a system that can, analyze its environment, make a decision, and then act on its own to achieve a specific goal. And then you've got the Oxford English Dictionary's definition, which hones in on this really fascinating idea: the difference between exhibiting intelligence and simulating it. I mean, is the machine truly thinking, or is it just an incredibly convincing fake? Believe it or not, that's a debate that is still raging today. So, what's the big takeaway here? The crucial point is that there is no one-size-fits-all answer. AI isn't one single thing. It's way better to think of it as this broad field, this huge constellation of different technologies, all aiming for the same thing: to build machines that can sense, comprehend, and then act intelligently. Now, the journey to create these intelligent machines, man, it has been a wild ride. A total roller coaster of incredible highs and some really crushing lows. Periods that researchers actually call AI winters. And this timeline really shows you those crazy boom and bust cycles. You got the super optimistic golden years right at the start where it felt like anything was possible. But then, bam, the first AI winter hits in the 70s because the tech just couldn't live up to all the hype and all the funding dried up. But then you get these huge public moments, these massive victories, like IBM's Deep Blue beating the world chess champion Garry Kasparov. And that just brings AI roaring back to life, eventually leading to the mind-blowing tools we have today. Okay, so how do we even start to categorize all these different types of AI? Well, it helps to think of it like a family tree with two main branches. One is about what an AI can do, its capability, and the other is about how it works, its functionality. So first up, let's sort them by capability. On one side, you have narrow AI. This is the AI we use every single day. It's designed for one specific task, like recognizing your voice on Alexa or helping a car drive itself. Then, on the other end of the spectrum, you have the purely theoretical stuff: general AI, which would be just as smart as a person, and super AI, which would blow past human intelligence in every single field. But for right now, those two are basically science fiction. Now, the second way we can categorize AI is by how it actually functions. The simplest is what we call a reactive machine. Think Deep Blue. It only sees the chessboard right now. It has zero memory of past moves. A step up from that is limited memory AI. This is what powers stuff like self-driving cars and ChatGPT. It actually learns from past data to make better decisions. And then you have the really future-forward concepts: theory of mind, where machines could understand our emotions, and self-aware AI, actual consciousness. Both are still totally hypothetical. All right, let's peek under the hood, shall we? We're going to look at two of the absolute core concepts that make all of modern AI possible: machine learning and natural language processing. First up, and you could argue it's the most important, is machine learning. This is really the engine driving modern AI. See, instead of programming a computer with a rule for every single possible scenario, we just feed it a ton of data and let it figure out the patterns on its own. It literally learns from experience. And machines learn in a few different ways, right? There's supervised learning, where we give it neatly labeled examples, like, here are a million photos all tagged cat. Then there's unsupervised learning, where we just dump a bunch of data on it and say, hey, find some interesting patterns in here for us. And finally, you've got reinforcement learning, which is pure trial and error. The machine gets virtual rewards for good choices and penalties for bad ones, kind of like training a pet. The second core concept is natural language processing, or NLP for short. This is the magic that bridges that huge gap between our messy, emotional human language and the cold, hard logic of a computer. It's all about teaching machines to understand, interpret, and even write like us. And you use NLP all the time, probably without even thinking about it. I mean, every time you ask Siri for directions, use Google Translate on a website, or deal with a customer service chatbot, and especially when you're using something like ChatGPT, you are tapping directly into the power of NLP. Okay, so let's connect all the dots here. Let's bring this all together and see what this long, sometimes crazy journey from the 1950s means for us, right here and right now. The really crucial thing to get is that the incredible AI we see today, everything from self-driving cars to ChatGPT, it didn't just appear out of thin air. No way. It's built on over 70 years of research, amazing breakthroughs, and yeah, even a lot of failures. Today's AI is standing on the shoulders of giants like Alan Turing and John McCarthy. Think about it. It all started with just a single powerful question posed way back in 1950. And from that one question, it has grown into a technology that is fundamentally reshaping our entire world, how we work, how we create, and how we talk to each other. And that leaves us with one last thing to think about. We started this whole thing by asking Alan Turing's question: can machines think? But maybe that's not the right question anymore. As these systems get woven deeper and deeper into our lives, the real question we have to ask now is, how will they change the way we think?